To solve another Leetcode problem, 330 pattern array. So for this problem, we are giving a sorted integer array nums at integer n. So we can add, or we're gonna call it paths, elements to the array such that any number inside the range from 1 to n inclusive can be formed by the sum of some elements in the array. So we're gonna return the minimum number of paths required. So let me first play on the problem. So for example, we are giving 1 and 3. So how many combinations? It can combine, first of all, let's check the first number, it's going to be 1. So it can combine and become a 1. Yeah. So what about this 3? It can become a 3 and 4. Yeah. So definitely 2 is missing. And also 5 and 6 is missing. Yeah. So this means if 2 is missing, so definitely we want to put a 2 inside. Yeah. So first of all, we're going to have a 1 because 2 is missing. But how can we find 2 is missing currently? And because currently we're going to check the numbers one by one. So the first number is 1. Definitely there's no 2, right? Now, our next number is 3. While we are checking this 3, because the minimum number can become is only 3. Yeah. So in this case, we're gonna prepare a 0 as a padding to the left side because it's gonna be easier for us to understand the problem. Yeah. So first of all, we're gonna have a value of 0. So the range is just 0. Now we have a value of 1. So the range is from 0 to 1, right? Yeah. Now we want to add another value 3. So if we add this value 3, what's going to be the range? So the range is going to be 0 plus 3, going to be 3, 1 plus 3, going to be 4. So it's going to be 0 to 1, 3 to 4. So it means this number 2 is missing. So if 2 is missing, what we're going to do? We're going to first add 2 inside because this is going to be the first number which is missing. Yeah. So if we add 2 inside, 0, 1, 2. So how many combinations? 0, 1 plus 2. So it's going to become 2, 2, 3. So 0, 1, 2, 2, 3 is going to become 0, 2, 3. Yeah. Now we have the next number, which is 3. Yeah. So if we have the next number 3, so it's going to become 3 to 6. And here is 0 to 3, 3 to 6. It means the total range is 0 to 6. Yeah. So this means it meets the condition from 1 to 6 inclusive. Yeah, because if 0 to 6 is inclusive, definitely 1 to 6 is also inclusive. Yeah. So 0 just means if we didn't choose any number, so it's going to become a 0. And this is going to be easier for us to solve the problem. Yeah. Now, we're going to define some variables. So we're going to define a variable I going to equal to 0. According to the I, we're going to check the numbers one by one. So this is for I. And we're going to define another variable S. So S going to equal to 1 from the beginning. This is going to be easier for the calculation. So this means from the beginning, there's only 0 to S minus 1 element. It means it is 0, 0. So from beginning, so the range is only 0, 0. So yeah. So this means from the beginning, so S means from the beginning, the range is 0 to 0. And also this S means the range gonna starting from 0 to S minus 1. S minus 1, it is 0, because this is gonna be easier for us to solve the problem. Yeah. Now we start to add numbers. Let's just check this case. So first of all, we're gonna put 1 inside. If we put 1 inside, what's gonna happen is for this S. Yeah. So first of all, this is just S. Now we're gonna add 1 inside. Yeah, it is 0 to 1. If we add 1 inside, what it become is plus 1 plus 1 here. It's gonna be 0 to 2. Yeah. So currently this means S equals to 2. Yeah. So this means S equal to 2, but the range is gonna be starting from 0 to S minus 1. It's gonna be 1. Yeah. Now we're gonna check the next number. Yeah. So if the next number is 2, it is okay, but the next number is 3. Yeah. So this means the next number. So for example, it is x. So the next number x gonna be more than current number, which is this s. Yeah. So this means if x is more than s, what are we gonna do? We need to have a path. The path gonna be s. So this means s gonna equal plus equal to s. Yeah. Let me make it right. Yeah. So this means s gonna update it to plus equal to s. Yeah, because 3 is more than 2. If this x current value is more than this number, so we're gonna double it. So basically, this means from 0 to 2, it's gonna plus a 2, it's gonna become 0 to 4. Yeah, actually, this means the range is from 0 to 3. Yeah. Now we're gonna add the last number, which is 3. Yeah, because 3 current number it is x3 is less than and equal to s, right? Yeah, because s is 4, x is 3. So yeah, we're gonna just plus 3 to left and right. So it's gonna become 0 to 6. Because here is 0, 0 plus 3, it's gonna become 3, 3 plus 3 gonna become 6. So 0 to 3, 3 to 6, it's gonna become 0 to 6. Yeah. So this means in this way, we're gonna have all the ranges. Actually, this s is 4. So this means it's gonna be 0 to 4 plus 3. It's gonna be 0 to 7. Yeah, actually it means it is inside of the range 0 to 6. Yeah, because this 7 is not included. Yeah, because our setting for s equal to some value, actually the range is 0 to s minus 1. Because this is gonna be just easier for the calculation. Yeah, so the condition is that we're gonna check the value of s. Yeah, if s is less than or equal to n, so this is our target, it is n. If s less than or equal to n, definitely it is okay because currently n is 6. Yeah, so this s, yeah, if it is less than and equal to 6, it is okay. But currently this s is 7. Yeah, because if we plus a value of 3, it's gonna become 7. 7 is more than 6, so we're gonna break out. Yeah, so we yeah, so we're gonna just break out the while loop because this is our while loop. We're gonna check s should always less than or equal to n. Yeah. Now let's just start coding. If we understand the process, basically it is a greedy idea. So as our numbers is sorted, so we don't need to unsort it. Yeah, but if it is not sorted, definitely we're gonna sort the number first. Because according to the greedy idea, we're gonna always choose the smallest number. So if we choose a number 3 first, if we didn't choose 1, this means 1 is missing. We have to patch 1 first. Yeah. So this is why we're gonna always choose the smallest number first, 1 and then 3. Yeah. As the number is sorted, so basically we don't need to sort it. And we just need to define some variables. I am gonna set it to 0 and s I'm gonna set to 1. Because s is just for all the ranges from 0 to s minus 1. And I'm gonna set a result to 0. Now I'm gonna use the while loop while s is less than or equal to target, which is this number n. Yeah. So yeah, if it is less than or equal to the target number, so I'm gonna have two conditions to check. So if I is less than length of the nums, so this means I is inside of the range. Definitely I will use this this value inside of the nums. So for example, the first value. So I have to check. Yeah, I have to check this value. Yeah, I have to check this value should be less than and equal to my current number. Yeah, because if it is less than or equal to the current number, definitely I can use it. Yeah, so s gonna plus equal to nums I. So this means I can use it, and I gonna plus equal to 1. Yeah, so this is for the conditions like, so first of all, we're gonna have 0 to 1. Yeah, so s equal to 1. So the range is 0, 0. Yeah, this is from the beginning. Now we're gonna choose the first number, which is 1. Yeah, so I is less than the length of the nums, and the nums I is 1 is less than and equal to Yeah, it is not n, it is less than or equal to s, this value 1. Yeah, so definitely we're gonna put it in, definitely we need to plus the value of nums to s, so s gonna plus equal to nums. So s is 1, 1 plus nums, s gonna become 2. Yeah. So now let me just change this to s. Otherwise, if the gap is too big, so currently, for example, we have 1, 2, 3. If the gap is too big, here is a 6. Definitely there's a gap. The gap is too big. Yeah, if it is 4, it is okay. It can be connected. But if it is 6, the gap is too big. So if it is too big, what are we gonna do? We're gonna pass a value of 4, and this value 4 gonna be the value of s. Yeah. So s gonna plus equal to s, gonna be that value, and we're gonna update the result, gonna plus equal to 1, and finally we're gonna return the result. Yeah. Now we've already finished. Maybe you're gonna think, oh, it's just a little bit coding, but actually this is really difficult to think about. That is why it is a hard problem. Even though it is a little bit coding, but it's really difficult, right? Because it's the greedy idea, and you have to set the s to 1. If you set the s to 0, basically it's really difficult. It's a lot of coding. You have to set the s to 1. It means the range is going to be starting from 0 to s minus 1. Yeah. So if s is more than the number of n, definitely we're going to go out of the while loop. Yeah. So this means if s equal to n, it is okay. But if s equal to n plus 1, if s equal to n plus 1, we're going to go out of the while loop. But the actual range is 0 to n. Yeah. So if the s equal to n plus 1, definitely we're going to go out of the while loop. But the range is actually 0 to n. It means 0 to 6. If it is 0 to 6, definitely it is 1 to 6. It is okay. Yeah. I think that's all about it. And the time complexity, because we didn't sort the nums, so the time complexity is going to be O(n). Definitely we're going to check the nums one by one. Yeah. And the space complexity is 1. We didn't use any actual space. I think that's all about it. Thanks for watching. See you next